Okay, so now we will look at how to write a concurrent server. So again, we'll continue with the example that we have been working on. So we want to add from 1 to up to a count value, and for each addition the server is going to sleep. So larger the count value, the larger more the time it takes for the server to compute the sum and send the result. And in the case of the iterative server that we went over in the previous video, we saw that even though a client would have requested to count only up to 5, if its request is reaching the server after some other client has sent a request, the server will process that particular client's request first. For example, if someone requests to add up to 1 to 100 and the server gets that request first, the server starts processing that, and just after receiving the first client's request, second client's request for say adding up to 5 comes to the server will still keep that in pending and focus on finishing the computation of the sum for values 1 to 100. This is the case for iterative server. But in the case of the concurrent server, we are going to see how we can have multiple threads running for a server, and each thread will handle one particular client. So the client that placed a request that will not consume much time will get its service done pretty quickly, whereas the client that placed the request that takes more time will face an appropriate computation time. Okay, so we'll see. So the client program is going to remain the same, because that's one thing we need to understand. It's kind of abstracted, so the clients are not going to be aware whether they are being served by an iterative or concurrent server. Of course, the longer the delay for a small request, it could indicate to the client that it's probably being serviced by an iterative server. But other than that, the client program should not be changed depending on whether it's being serviced by an iterative server or a concurrent server. So that's what we should take care of. So the client program should remain the same. And what are the client program we went over for the iterative server, iterative process should still now work for the concurrent process. So now let's just look at the code for the concurrent server. Um, so I input the main method. I have a class called Summation Server. That's where the main method is declared, and I input the port number at which the server is going to run, and then I call the server socket constructor and pass the port number at which the server will be running, and waiting for incoming client requests. And then I have an infinite while loop where the server is going to wait for client requests. And so the accept method is a blocking call. So the client is going to the server is going to just wait for the clients to contact it, and once a particular client contacts a server, the server is going to kind of the accept method is going to return the socket object. And now, instead of doing all the summation that we did in the previous case, everything within the main program by the main server itself, what we are going to do is we are going to spawn a thread. So I have developed another class called Summation Thread. Within the same file, you can have that within the same overall Java program. So this is this is again any name you could give. So I just call Summation Thread. And then this is what you should do. Extends is a keyword, and thread. Thread is the name of a class in Java that implements a threading functionality. You should have learned thread in operating systems. So all the threads share the same memory, and a process can spawn multiple threads, and the threads could be scheduled to run independent of each other. Okay. And so in the thread class, I have this member variable called socket. So this is an object, a class name. Socket is the name of a class, and this is the member object I'm creating within the thread class. And in the constructor for the summation thread, I'm going to pass a reference to the socket object, and that's what I'm doing here. And so let's see the construct, how I call this. So the accept method is going to return the socket object reference. So I'm going to pass that as the argument to the summation thread constructor. So again, I could name this as anything. I just name it as thread. You could name it anything you want. So this is the object name, and this is the name of the class. So this is the class I just created, summation thread here. And then I need to call thread.start. So the start method is going to activate the run method. So the thread method inside the thread class itself, there's a run method implemented, but that's not going to do anything special for you. So if you want the thread to do something more specific than what you want, then you have to implement that functionality inside the run method, and that's what we are doing here. So the run method that we have here will implement the functionality of adding up all the values from 1 to up to count and then sending the result. Okay, so already we have a reference to the socket that corresponds to the client. So that's because that's what we passed from here. This client socket, and an object of class socket that was written from the accept method is passed to the summation thread. So we have access to that. So we can use that to contact that particular client. So that's what we are doing. So we are going to now use buffer reader to read from the socket the count value sent by the client. So this is similar to reading from the socket. So I call client socket because this is a member object I have created here. So I can call client socket dot get input stream and then input stream reader buffer reader, and then I call the readline method to read the count value sent by the client, and then go over the for loop to find the sum, and everything is the same here. So I'm going to sleep for every time I am doing that addition for 200 milliseconds, and then I'm going to send the sum. So I have to use the print stream class. So I use the get output stream method called on the client socket object. So I then call the println method on the print stream object and send out the sum, flush it, and close this client socket. So this particular server thread now, so this thread has serviced that particular client. So if a client has requested to do addition from 1 to up to 100, that thread will spend more time, whereas another thread that is requested by client to sum up 1 to up to 5 will spend less time. Each thread can run independently. Okay, so what happens at the main server, main program here, the thread, that particular thread to handle the client gets started, and then the control goes back to the while loop, and so this is actually a separate thread on its own. The main program itself is now a separate thread. So the server socket is waiting for incoming client request, and the other threads are running in parallel, and they can service each of the individual clients. Okay, so that's what is happening. So this runs in infinite loop, so the server keeps waiting for client requests. So let's run them and see how it shows up in terms of the delays. So the client programs need not be compiled, so it's just a server. So I stopped my previous iteration server. So let me compile my concurrent server. Okay, so I use the same summation server name for the main for the class of the main function. So now it's a concurrent server running. So let me do this. So I'll start the 50 thing first, and then the 20, and then the 5. So the 5 should be done pretty quickly, and then the 20, and then the 50 is still running. It should complete soon. So that's what it is. Okay, so the clients are handled independently now by one thread, by different threads. So one thread per client. So depending on the workload requested by the specific clients, the threads will take now the appropriate time. Okay, so you don't need to wait for requests that reach the server earlier than your request, and just because of that, if that client has requested for a long computation task, you don't need to wait with the concurrent server. Whereas with the iterative server, you have to wait because the requests are processed only one at a time sequentially in the order in which they were received. Okay, so let me stop this.